Welcome back for another Pytorch video. I thought I would just make a quick video on how to initialize weights for a network. Pytorch has inbuilt initialization which works quite well normally, so you wouldn't have to worry about it. But if you want to know how to change it, that's what we're going to learn in this video. So first of all, there are a bunch of different initialization techniques like Xavier initialization or Kaiming initialization, and you can read more about them in the Pytorch documentation. I'll link to it in the description. But for now, let's just get started on how to initialize our network. So what I have here is a very simple CNN example. Really nothing special here, just a conv, a pool, another conv, and then a linear layer. So what we're going to do is we're going to define another function, define initialize weights, which just takes self. And then what we're going to do is we're going to do for m in self.modules, and this is tracked by Pytorch. So when we define all of these modules here, the conv, the max pool, and linear, etc., these are all stored in the self.modules. So we're just going to go through each module one by one. So this would be the entire network essentially. If we just do print m and we run the function here, like this, we would get back the entire conv1, where's the pool? Yeah, pool, conv2, fully connected. Yeah, so we get all of them in this case. So what we're gonna do is we're gonna say if is instance m, so the current module, if it's a conv2d, we're gonna do, so you could use a variety of different initialization techniques. We're just gonna do the Kaiming uniform, and then we're gonna do m.weight. So what this means, we're just gonna perform Kaiming uniform on the weight of that specific module, and we're only going to do if it's a conv2d. And then also we're going to do so you can define a bias in the convolution. It's default, the default is true, so it initializes a bias by default, but we can do if m.bias is not none. We can do nn.init.constant m.bias, and we're just going to set the bias to 0. Yeah, but you could do other things as well. You could do, now we don't have a batch norm in our network, but let's say we would have. Okay. m.nn.batch norm 2d. Let's indent this. Yeah. So what we're going to do is we're going to do nn.init.constant m.weight, 1, and this is just standard initialization for batch norm. And then the bias, the bias, and the bias should be 0. And you could also do something like else if is instance m, nn.linear. Indent this. Then we would, for example, we could do the same thing here as we did for the nn-conv2d. You could also do different things. Maybe you want to have normally distributed values or something like that, or you want to use Xavier, whatever. And then nn.init constant m.bias, we'll just set it to 0. So this is just an example of how you initialize the weights, and then you would call the initialize weights after you defined all of your modules. That's it. Hopefully this video was useful. Thank you so much for watching the video, and hope to see you in the next one.